Welcome back. Now, aside from our character, one of the more important classes in our game is going to be the weapon class. So we're going to create our weapon class in this lecture. And we'll add some basic components that all weapons should have, as well as an enum for the weapon state, so we know how to treat the weapon depending on the state that it's in. So let's get started. So we're going to need a weapon class. So I'm going to right-click and add a new C++ class, and our weapon can simply be an actor. So I'm going to choose actor, click next, and I'd like to keep our weapon class in its own folder called weapon. That way later when we derive more classes from weapon, we can stick all those weapon classes in the weapon folder. Now this class is going to be called weapon. So let's click create class. So we can hit no on this pop-up message. And here in Visual Studio, I have my weapon class. Now I don't need the rest of these tabs open for now, so I'm going to right-click on weapon.h and select close all but this. And I can use Ctrl-KO to open weapon.cpp from the weapon header file. Now because weapon is in the weapon folder, we don't need this weapon part here as we've seen, so changing the include to just include weapon.h will fix all compiler errors. So let's head over to our weapon.h file, where we have a constructor, begin play, and tick function. Now, just like I did with the character class, I'm going to remove these comments as we don't really need them now. And I'd like to add the basic components that all weapons should have. So I can make a private section here for those component variables. And I'm going to go ahead and move tick up here to the public section just under our weapon constructor. Now in the private section, I'd like a mesh for the weapon, and all of the assets we have, if we go into our assets folder and check out military weapons silver, in weapons, I see that these are all skeletal meshes. So my weapon class definitely needs a skeletal mesh component. So let's add one of those. It's going to be a U skeletal mesh component, and I can call this weapon mesh. Now weapon mesh is getting a U property, of course, and I'm going to make it visible anywhere. And we'll be able to set the skeletal mesh on our component from blueprints. Now I'll go ahead and give this a category and call the category weapon properties. Now in addition to a skeletal mesh, we're going to need some sort of overlap volume so that we can enable equipping this weapon when the character is close. So I'm going to forward declare a uSphere component and use a sphere component called area sphere. And area sphere can get the same U property as weapon mesh. Now we'll have more components as we develop this weapon, but for now I think this is good. Let's go ahead and construct these in weapon.cpp. Now the first thing I'm going to do before we construct these components is set beaconEverTick to false. If we decide later we need our weapon to tick, we can always change this, but I'm going to set it to false for now. And I'm also going to remove these comments as they're not really helping us any. And we can construct our weapon mesh. So I'm going to say weapon mesh equals create default subobject and use uSkeletal mesh component. And I'm going to call this weapon mesh. So I'm going to say weapon mesh setup attachment root component. Now later on I plan on being able to drop this weapon, and I'd like the weapon to bounce off of the ground and the walls whenever we drop it. So I'm going to set its collision response to all channels to block. So to do that I can say weapon mesh set collision response to all channels, and the collision response will be collision response block. So it's set to block all. Now once we drop it, I would like to ignore the pawn so the pawn can step over it and run through it without colliding with it. So I'm going to say weapon mesh set collision response to channel, and I'm going to set its response to collision channel, and I'm going to choose pawn and set that response to collision response ignore. Now, this is all, of course, when we drop the weapon, but the weapon doesn't start off in that state. It's going to start off in a state where we can just walk up and pick it up. And so from the start, I'd like my weapon mesh to have its collision disabled. So I can do that by taking weapon mesh and calling set collision enabled to e collision enabled, no collision. So we can keep these collision settings as is. And once we want the weapon to actually start colliding with things, say we drop it or throw it, then we can set its collision enabled to, say, physics only or Aquarian physics or something like that. Now, we also have our area sphere. Now, I'm not getting any include errors for using the uSkeletal Mesh component type. That may change from engine version to version, so if you do get include errors, make sure you include the header for that. I can get away with not using it here in the actor class. But to use uSphere component, I am going to need to include the sphere component header file. And I know that that is in components/sphere component.h. So I have that include, and I'm going to construct my area sphere. So I'm going to say area sphere equals create default subobject uSphere component. And this is going to have the name simply area sphere. And I'd like to attach area sphere to the root as well. So I'm going to say area sphere setup attachment root component. Now let's talk about this area sphere. This sphere is going to be what we use to detect overlaps with characters. And once they overlap, we'd like to be able to pick up the weapon. We can display some sort of pickup widget and set the item state and all that good stuff. But here's where this type of thing differs in a multiplayer game versus a single-player game. In a multiplayer game, it's a good idea for important things like this to be done on the server only. So I'd like to only have our area sphere detect overlap events if we're on the server. So therefore, I'd like to take area sphere and call set collision response to all channels. And I'm going to use e collision response ignore. And that way, it's like the area sphere doesn't even exist. Now, what I'd like to do is disable collision for the area sphere and the constructor, and then in begin play, I'll enable it, but only on the server. So right here, I'm going to say area sphere set collision enabled and pass in e collision enabled no collision. So on all machines, this will be set to no collision, but on the server machine, we're going to set it to actually enable collision. So before we move on to that, I noticed that we don't actually have a root, so I'm going to set the root to be the weapon mesh. So let's call set root component and pass in weapon mesh. Now, if we are on the server, then I would like to enable collision. But rather than doing it here in the constructor, I'm going to do it in begin play. So we can check to see if we have authority here and enable collision. And then later when we add overlap functions, we can bind those here in begin play if we're on the server. So I'm going to place an if check here. Now what we could do is call get local role and check to see if that's equal to enet role authority. And if that's the case, we can call set collision enabled on the area sphere, and instead of no collision, we can use something like Aquarian physics. And we can also set the collision response to the channel that we would like to overlap with, which is going to be the pawn collision type, as that's the collision object type of our capsule. So I'm going to say area sphere set collision response to channel. Now the channel is going to be e collision channel, and I'm going to select the pawn collision type, since that's the collision type for the capsule. And the collision response is going to be e collision response overlap. So we could do this, but there's an easier way to check to see if our role is authority, and that's with the has authority function. This is the same thing. It checks the local role, and if that is equal to role authority, then has authority will return true. Now this will be the case if our weapon is a replicating actor. That means the server will be in charge of all weapon objects. So for our weapon to have authority only on the server, we need to set it to replicate. And we can do that in the constructor. The actor has a bReplicates Boolean, and we can set that to true. Now, the last thing I'd like to add before we wrap up this video is an enum for the state of the weapon. And we can add this up here in weapon.h just before the class declaration. Now, I'd like to call this enum weapon state. And it's going to be a scoped enum. In other words, I'm going to make an enum class called eWeaponState. And use uint8 here. So our enum constants are unsigned 8-bit integers. And this is also going to be a blueprint type. So I'm going to give it a uenum with blueprint type. That way we can use this enum as a type in blueprints. Now for eWeaponState's enum constants, I'm going to prefix them with EWS for eWeaponState. And I'd like an initial state. This will be the state for when the weapon is just sitting there in the world, it has never been picked up yet, and our character can walk up and pick it up and equip it. So we have the EWS initial state, and I can give this a uMeta macro to set its display name. And this will be for its display name in blueprints, and I'm just going to call this initial state. Now, in addition to initial, I'd like a state for when we actually equip the weapon. So I'm going to add another enum constant called equipped. And its display name can simply be equipped. And then I'd like another enum constant for when the weapon is dropped. So I'm going to call this one dropped. And this is where we can turn on physics, turn on the collision, and let the weapon bounce around on the ground. So I'm going to give this one the display name dropped. And of course, most enum constants will have a default max constant. And this one is going to be called EWS max. And I'll give it the display name default max. That way, if we ever need to know how many enum constants are actually in this enum, we can check the numerical value of EWS max. All right, so our weapon defines this weapon state enum. Why don't we go ahead and add a variable of this type to the weapon class? And this could be private as well. I'm going to stick it right down here. eWeapon state, I'm going to call this weapon state. And I'll make this a U property. And I'm going to go ahead and make this visible anywhere so we can see it from blueprints. But I'd like to set this variable from game logic, and that's mostly going to be in C++. If later you decide you'd like to expose it to blueprints, you can, but really we have no need to do that. So we can compile our code. And back here in the editor, we can create a blueprint based on our new weapon class. So I'm going to head over to my blueprints folder and make a new folder and call this weapon. And in the weapon folder, I'm going to right-click, create a blueprint class, and with all classes expanded here, I'm going to search for weapon and choose the weapon C++ class and select that. Now I'm going to call this BP weapon for now and double-click this, and here's our weapon class. Now I see that I have my weapon mesh and my area sphere. Now I can set my weapon mesh right off the bat by clicking the drop-down next to skeletal mesh, and I'm just going to select the assault rifle. I'll use that for now. So there's my assault rifle, and I see that it's a little offset, so I'm going to move my area sphere over just a bit and up to the center of the weapon. And I think I'll go ahead and increase the sphere radius just a bit, so that way we can pick this thing up when we're reasonably close. And selecting BP weapon self, there's my weapon state, and it's set automatically to the first enum constant, which is initial state. So we now have a weapon. I'm going to compile and save that, and why not, I'm going to drag one right here into the level, and now we have a weapon. Now we haven't programmed any functionality for this, so it's not really going to do anything if I overlap with it, but I can still see that it exists here on my client instances of the game, and I see the weapon here on the server. So in this lecture, we created the weapon class. and we added a few components to it, as well as a weapon state enum that we can use to determine how to treat the weapon from a code standpoint, depending on its current state. Now, we'd like to show a pickup widget that will pop up and inform us that we can pick up the weapon as soon as we overlap with it. And we'll handle that in the lectures to come. Awesome job. I'll see you soon.